started whenever you're ready.
Okay, amazing. Well, thank you so much to Callie for having me here today. I'm super excited to be chatting with everyone. I can give a super brief intro to myself, and then really today we're here to learn about the coding interview. And I'm hoping that kind of everyone is able to walk away understanding what it is, what it's testing for, and kind of be armed with kind of a method with which to kind of approach these types of interviews. And yeah, totally. If anyone wants to camera on, we can try to keep this as much of a live conversation as possible. I know this is the first time I'm working with you all, so I'm less familiar exactly with your exact skill levels and kind of questions. So the more you can ask questions, the more I can kind of tailor what we talk about here. And so feel free to type any questions in the chat, or also feel free to interrupt me. There's also going to be a lot of interactive components during which I'll be expecting some answers. But to kind of first get started, hello everyone, I'm Sophie. I am the founder of Formation. We are an adaptive learning platform for software engineers, and we really focus on helping people from, non-traditional and also underrepresented backgrounds break into some of the top tech companies. We generally focus on people more at the mid to senior level career-wise. But we do also work with people kind of earlier as well. Um, and the thing to kind of, I guess, maybe share about our program is that we have an adaptive learning platform. It means that we don't have a fixed curriculum at all. Our platform is basically constantly benchmarking people's skills and using AI to determine what material and what lessons that you should be completing to kind of master the skills that you need to succeed in the interview process. Prior to Formation, I was an engineer myself. I was at Facebook/Meta and Nextdoor for a long time, and I was definitely one of the people that was very involved in thinking about our interview, hiring, onboarding practices, especially at Nextdoor. I probably interviewed a few hundred people. Across the two companies. And I've worked with many hundreds of engineers at this point now, trying to learn how to navigate various job hunts at this point. So definitely excited to try to transfer any learnings that I've had on this journey over to everyone here. So I guess to get started, with this topic. I'm not sure how familiar people actually here are with the coding interview. Um, and maybe a quick show of hands, has anyone done a coding interview here live? Yes-ish. I'm curious, I have a question. What um, why do we think the coding interview kind of exists? And do we think it's like a good test of engineering skill? I think anyone can jump in or also type in the chat, up to you.
From what I've heard, I think it was a good test of engineering skill. But as time has gone on, it's not that it's not testing well, but in some ways it's not testing well. So I think it's necessary because at the end of the day, like we have to be able to think about data in a way that's going to be helpful for our employer. But then you also have those that are like, well, my technical interview was a lot harder than the work that I'm actually doing. And so it's like, are we trying to like sift through the crowd, or is it just, we just haven't updated our actual practices to interview people in a way that will, one, be helpful to them, but two, will actually be helpful to us as a company. So I think it's like a both and, where like, I understand why they do it, but also, are they moving with the times? And I don't know
Yeah.
if they are actually.
One of the reasons that I asked this question too is that I think I see and especially, as part of coding with Callie, it's really awesome that, there's such a focus on project and real work. And that's really what we're here to do, right? Is to build like real products as software engineers. And so a lot of times, like, what we're about to do may feel like a big departure from, what you guys are probably doing day to day, which is building real stuff. And so one of the things that I want to kind of maybe contextualize is kind of why the coding interview is the way that it is. So for example, we're not going to get into this topic really today, but has anyone heard of the concept of like binary trees, for example? Or just trees in general? Yes. And that can feel like, oh, it's a very made up construct, right? Like what does this have to do with my day-to-day? Has anyone thought this before? Kind of. And oh yes, I love that. That's actually the exact kind of example that I was going to bring up, is that most engineering projects last more than an hour. I think that Callie was just talking about how most projects that you're going to be working on, you're going to be working on for a week, a month, years even. And obviously an interview just can't last that long, right? I think that most companies, if they had a choice, they would much prefer like a contract to hire type of situation, to be totally honest. However, it's usually not within kind of the reasonable expectations of a person seeking a job to be like, oh, you'll interview me for a month, right? And that's really like a way better test of engineering ability. But the problem is that usually, we only have, or from the company's perspective, like an hour to assess technical ability. And so really what we've done is we've stripped kind of the interview of all of the fluff that takes up time, right? Removing all the business context of like what these data structures can represent, right? And so like you hear a lot about these node objects, and these node objects really are just objects that don't have any intrinsic meaning to them. But, you are working with these types of algorithms on the day all the time. And Vika here has mentioned the DOM structure, right? That's just a tree. And so the ability to iterate through, manipulate, edit, modify trees effectively is very much part of our day-to-day job. But in kind of as part of the interview, we don't have time to get into the complexities of like assigning meaning to our objects. And so the kind of problems then can feel a little bit contrived. However, one of the nice things about it is that it allows us to hyper focus on just the algorithmic or coding logic portion of the problem solving process without thinking about the business context of like, what should the application do in response to this user behavior, right? Like we get to focus just on the algorithm itself. And so in addition to the fact that like it is kind of trying to simplify the problem for the context of the interview, I actually think it is a great way to strengthen your programmatic ability in a hyper-focused way. I've made kind of this analogy that algorithms are like squats, where, if you're an athlete, you're probably not like doing squats on the field, right? Like that's not like a skill that you're doing when you're performing in a game, right? But that doesn't mean you don't practice squats or sit-ups or whatever to practice specific isolated muscles. And I think data structures and algorithms and coding kind of problems of this size are a great way to do like a squat where you're focusing on just the programmatic ability without like, the alternative kind of analogy would be if you only practiced a sport like soccer or something through scrimmages, right? Then you're not really focused on, you're not maybe practicing specific dribbling skills in isolation enough to strengthen that muscle. And so I think that, one takeaway hopefully from today is also that, this is going to be real. This is, testing real engineering skills, and it's actually good practice to a certain degree to incorporate into kind of your growth as an engineer. Okay, so I want to today kind of introduce this methodology. We talk about it at formation a lot. It's called, we call it the engineering method. And the closest analogy to what it is kind of the scientific method. Now, I call this the coding interview, and it's kind of misleading because the word coding is in it, right? Which makes people think that it's only about coding a little bit, right? But really, it's not just about that. Like, what are some of the other things that people think that you guys think are being tested besides coding?
I would also say like your ability to work as a team, like if you're a team player, because most of the time that's exactly what you're going to be doing. You know,
Yeah.
it's breaking code with a bunch of people. So
Totally. Especially at smaller companies where you're likely interviewing with the actual people you're going to be, working with, like we're having a conversation right now and informing all kinds of biases about like what it's going to be like to work with you, right? Yeah. Communication is definitely a big part of that. It's fascinating to me how it's very hard to translate kind of like an algorithmic structure into words. And that the practice of doing that is like I've seen like bunch of you know we call them fellows, like try to communicate something and use like spend minutes of time trying to explain an algorithm, and then we'll slightly reframe it and instantaneously people will get it, right? And so kind of that translation layer of like getting an algorithm out into a form that other people can absorb and work off of is really important, because if you can communicate your ideas with your interviewer, then you actually can have a collaborative environment where your interviewer can actually help and work with you. And if you can't communicate, then you're kind of on your own. A lot of this is around communication. Yep. I would say that there's some additional pieces here, and we'll kind of get introduced to them as part of the engineering method. But one of the things is actually problem exploration. So for example, if I am designing an application and I ask you, should we optimize for, what do you guys think is the right question or answer to this? Should we optimize for reliability or should we optimize for speed in general when we're building, you know, software systems? Which do you guys think? Feel free to just
Well,
jump
it
in.
depends on what the company is desiring. So like, I know some people might be okay with, like some people will sacrifice reliability because they're desiring something to be quicker or
Yeah.
something like, so it might just depend on what the company is looking for.
Yep. And I would say actually that's the correct answer. You absolutely cannot answer any question, like pretty much any question that's of the form, like what's the best way to do something, what's better, A or B, like without that context, you cannot engineer a solution for. And so it's actually the same thing, right? And again, the entire problem solving process in the coding interview is just entirely mirroring a typical like engineering problem, right? And so just every step is just a little bit more condensed, right? And so, in a typical software project, you might spend a week just exploring the problem space, right? But in an interview, you have maybe 10 minutes, but you're still doing it. And so the ability to explore the problem and even understand what is being asked as part of it, right? I would say there's also like testing. This is missing a lot, where like being able to come up with what are the edge cases going to be, and then making sure that your kind of solution kind of meets all the needs. Anyway, let me actually quickly share screen and we can kind of, I'm not seeing the, oh, I think this is right. And then I'm going to walk through this thing that's just publicly available on our website as well. So you can go back through and read it more thoroughly. But just as a quick walkthrough of this kind of engineering method, as we scroll through, I will point out that here is step 5. Step 5, build it, is basically coding the solution. And what that means is that it is only 1 out of 6 total steps here. And I think this is one of the kind of first, I don't know, I say like this is the most common interview mistake that I see people make a lot for many things, but this is definitely one of them, is like people jump into coding way too fast. And there's so much to do before we get to that point. And so the first thing kind of to do is to really thoroughly understand the problem. Like usually the first thing that you should be doing is not trying to problem solve at all. The first thing that you should be doing with any problem is actually asking questions, almost always. Sometimes it is because there's intentional information left off so that you need to solve the problem. And sometimes it's just to kind of build your own understanding of the problem space. So I think that generally you want to be asking clarifying questions, looking for edge cases and figuring out what to do in those edge cases, as well as kind of understanding what's in and out of scope of this particular problem, right? And getting things out of scope of the problem is actually great because it limits the amount of stuff that you have to think about. As part of this also is coming up with a bunch of your own kind of examples. I can't tell you how many times I've seen an interview where where someone comes up with their own kind of example after thinking they understand the problem, and then the output they come up with actually is not correct. And it's like, nope, you're actually not understanding kind of like what the problem is. And it's, if you come up with that example, you can align on that and eliminate that as like a problem much earlier on. I can't tell you how many times halfway through a problem, like 30 minutes into an interview, we realize that the person's been misunderstanding kind of the problem this whole time. And so coming up with your own kind of happy case examples is a good first step. And then obviously also coming up with, a bunch of edge cases. There's edge cases. These are some examples of edge cases. Obviously, it depends on the problem, but things like negative numbers, invalid input, out of bounds, what you should do in all of these cases are examples of things to kind of look out for. And so as we kind of go through each of these steps, let's try practicing applying them to a problem or two. So I'm going to give a first problem is simple, straightforward problem. Given an array of 0, 1s, and 2s, return a sorted array. And so let's say you're given this problem in an interview. What's kind of the first thing that you might try to do or say? Am I allowed to use built-in methods? What built-in methods are you trying to use? Perfect. So by the way, I love this answer, and I actually think that this is the correct first thing to say, to be totally honest. And a lot of people shy away from that because they're like, oh, you must not want me to just use sort, right? But I actually think this is and I think that you should say it and also point out what are some of the flaws of this approach, right? I guess I'm sort of showing a preview of what's next, but a big part of this interview is actually usually identifying not just one way to do something. Your interview is not about getting the right answer. It is about observing. If that was the case, that, by the way, then everything would just be a take home, right? You know, like, why spend an hour of time watching you do it? Just like give me the answer after you've solved it and see if it's correct, right? And the reason is because they're watching we're watching the whole interview process and the journey to get there, and not just the answer itself. And so, so that's a good question. We'll get to the sort later, but let's say we obviously can't use sort as the answer to that question. Ascending or descending order. Perfect. So, you know, the way I usually like to ask these questions actually is always through an example. So even a question like this, I might say like, okay, so is it ascending or descending? And then immediately encode that in an example, right? So I would actually type this on screen and be like, so for example, if the input is 0, 2012, is it 0122 or 21 whatever, right? And so let's say that it is ascending. Callie, did you want to
Yes,
say
I
something?
did. I was wondering, do you typically in coding interviews not get example inputs and outputs? Or like, is that up in the air? Because I feel like the last one I did, they gave me a whole test suite and I just had to pass the test suite and it was like lovely to see the inputs and outputs. But now I'm like, wait, I have to make those up myself.
So that's an interesting, so I think that there's good ways and bad ways to execute an interview. And so if I was talking to a bunch of interviewers, I would say like, hey, you should provide some examples. But I always, the way that I try to, you know, teach people is that I don't want it to leave it up to the interviewer to be a great interviewer. And to be totally honest, you know, I also relate. I remember my first coding interviews that I conducted myself. And it's really hard to be a great interviewer, right? Like, and to give the right hints and to support enough, while also being the evaluating figure. It's hard, right? And so, you know, sometimes people are just not good interviewers yet. And I just want to give everyone the ability to independently take that into your own hands if you're not provided a perfect test suite, right?
If you're not provided example inputs and outputs, like I would think my question would be like, do you have some example inputs and outputs? Or do you just, if they're not given them to you, do you just like start, because like you just started writing them yourself, or would that be like not a good question to ask if they
Yeah,
didn't?
no, I think that's perfectly fine.
Okay.
Can you give an example? And to be fair, I do think the vast majority of people provide at least one example.
Okay.
Now, that being said, I also think a separate thing is I think it is actually atypical to provide an example test suite. And to be totally honest, I would say that's actually not the ideal interview. Like, I would not provide a full test suite. And the reason for that is that, because like, um, this is another kind of question people ask is like, can I ask like what the right runtime and like runtime for this algorithm should be, right? And the thing is that, like, when you're solving problems in the wild, like, again, this is trying to mirror real engineering, right? When you're solving a problem, a brand new problem that you're building an app, no one's in your ear being like, this should be O of N, you know, like, you don't know. You actually have to figure out what's the most, right? And so like knowing the right runtime is actually, I would say, a hint, right? And same thing with like building an application, like you don't know what inputs, right? Like, and part of the engineering mindset is like constantly thinking about, you know, what's going to go wrong, right? And so like, and to the point that I actually think people's brain chemistries change. Like, engineers are sometimes like really annoying to just like plan things with, because they like are constantly like, oh, what if this happens? Like, oh my God, let's not worry about it, right? But it trains your brain to think about, it's always the last 1%, right? And if something goes wrong only 1% of the time, in a lot of fields, it's fine. Something going wrong 1% of the time as an engineer is like horrendous, right? Like, imagine like every 100 times you did an operation just didn't work, right? So you have to develop the ability to figure it out and come up with those edge cases. So I do think it's typical that you'll get at least one happy case example, but I would say it's very, very common, and I think actually desirable to not have a ton. And it's your responsibility to come up with that. And finally, I also like to come up with examples for the reason I mentioned previously, because by walking through the example yourself, you actually start the problem solving process. A lot of times people
yeah.
can't solve the problem right away. And this is something I say you have to be comfortable with. A lot of times people panic because they see a problem they don't immediately know a solution to, and you're almost like, oh my God, am I ever going to know the solution? Like, and you're panicking, right? You should feel comfortable with the idea that for the first 30 minutes of an interview, you're not yet going to know the solution. And that's okay. Right. And so sometimes though you get totally stuck and you're like, well, I just don't know. I don't know. Like, I don't have a step I can take forward. It feels like, you go from no solution to solution in one step, and that's not the case. And so I think coming up with examples and just like, how did I even figure that out manually? Right. So lots and lots of reasons for kind of coming up with lots of examples.
Right. Well, thank you so much. Yeah, I'm sorry. I'm like getting so intrigued by all this, about to break out my leak code.
For what it's worth, I find leak coding / solving these problems can be quite fun if you kind of approach them in the right ways. But yeah, so that was a good question. So ascending or descending. Okay, so we've gone through one question. What else, guys? What other questions?
So I guess you could ask.
So this is a great, interesting question. So my commentary on this question is, I want to know why you need to know the answer to this.
Well, sometimes like you've got to handle it differently. But if you're getting an empty array, you can just return it straight away. You don't have to do everything.
Correct.
So if I know it might be empty, I could put that straight away and take care of all those cases.
Yeah. So yeah, I do think that like it's worth kind of noting here. Empty array should return empty array. If I were to ask that question, I would encode it kind of in my list here. I'd be like, okay, so I'm assuming if you get an empty array, it's also empty. Now, the one thing that I would say is generally a question should ideally impact how you're about to approach the problem, right? And so if you don't need this information to problem solve, it's actually not necessary for you to ask that question. And because it's not necessary, it can be seen as like, it kind of is just like wasting time, right? And so it can be seen as like, again, not as useful as a question that you need the answer to, right? So like, if the empty array case would change what you would code, then you should ask it. But I would say like, if someone wrote this, for example, if input dot length equals 0, and then I return, this, I would actually say this is not ideal because this should be handled by the logic of the rest of your code, ideally, right? And it shouldn't be special cased. And so as a result, since we don't need it, we shouldn't ask questions just to ask it. Like we should need the answer to this question just to proceed with our problem solving. But that is a good question for us to take a learning from. If you loop through,
Sorry.
yeah, sorry.
Question about repeating numbers. So like, let's say you have two twos. Like, what do you do with them? Do you combine them into one?
Nope. So, and I think in this previous example, we're seeing this already. So like in here, there's two twos. So in this case, if there's repeated numbers, you just continue. And in this case, it should be unchanged. Okay. Let's go back to kind of here and just maybe take a look at some of the things to look out for edge case wise. Empty cases, by the way, in terms of arrays, sometimes empty cases are need to be treated differently because it represents a different state. And again, if it changes your logic, it's good to ask about. So you have to kind of determine, oops, sorry. we're here.
So I guess like bad data, like you said, if there's a string, should it then be like an ASCII, uh, considered an ASCII number or
Great. Yeah, I think that's a good question. Basically, it's like all forms of the question, am I guaranteed to get an arrays of just 0, 1s, and 2s, right? Like, do I have to handle even if there's 3s, right? Like, what do I do in my algorithm, right? And I think that is an important question because it determines like whether you need to deal with that at all, right? Like, what should we do if it's like, 0, 1, 3, or even S, right? And so we're gonna say this will not happen. So this will not be something that we have to handle. Let's actually try to practice with another question. So let's say we're given a timestamp, like 10:23, right? Give me the angle between the hour and minute hands. You're given this problem. What are your first reactions to this?
Feel like I would really need to take some time on the happy case to like really make sure I understand like
Yeah.
what I'm doing, and like I would want to like manually try to figure it out. So I would be like, okay, let me just take this example of 10:23 and let me figure out where the 10 is pointing, where the 20, how would I even get an angle from this? And then I would hope
Yeah.
that questions would come to me as I'm
Yep.
trying to figure out the angle
Yep.
myself. Is that valid, or should I have these questions already in my head? Because I feel like right now my first question is like, how do I figure like where's the
Yeah.
10, where's the 23? You
Yep.
know.
So totally. And actually, this is a problem that it's atypical that I don't give examples actually, but I actually don't usually give examples for this one because it like is so kind of, once you know how to compute it, it's like that's the whole point. And I think this is one of the problems that illustrates that like walk through happy cases like point the most, because really you just start solving it manually and it helps you like go through it.
I think I'd probably wonder like, do you want to a certain number? Like, right, because there's 2 angles for each one, right? So
Mhm.
I would probably ask like, which angle do you want? Do you want both
Yep.
of them? And like, would you want it in an array with like both options, or one, like, I guess so that would be, but I'm only getting to that question by starting to think through 10 and 23 and where.
Yes, exactly. But see, that's and the reason that this question is good is because clearly you're walking through like an algorithm in your head and you're like needing to know which one in order to proceed, which is why it's a good question, right? Like and if you kind of solve the problem manually and you come into roadblocks, and then you can like start asking these questions. So like I think, yeah, so in terms of like there's 2 angles whenever unless it's like the 180 case, but like there's always 2 angles, so you always want to return the smaller of the 2 angles. So the angle should be less than 180 always, or it could be equal.
Now I feel like we should just do it. This feels really fun.
We can do this problem. There's some other kind of clarifying questions that I sort of expect with this. Can anyone think of any? Related to the fact that it's a time, like what kind of inputs might like throw you off here?
I would make sure I'm not receiving like military time.
That's actually a good question. People do ask like, is this like 12 or 24-hour clock? That's a really good question. So let's just say it's going to be up to 12. So not military time. I do generally ask for the invalid case. So like, will the time be valid? Like, will we get something like 1266 type of thing, right? So nope, no invalid. And by the way, when you ask these questions in interviews, almost always it's like no invalid case will be there. And it feels like it's a waste of time because like they always just say no invalid cases. However, you should explicitly eliminate that as a thing. Like just the fact that you've thought of it is kind of a quick check. Now, I wouldn't spend a lot of time on it, but like it is good to like check. Well, the time come in different formats. So it would always be HHMM. And one of the things that people ask sometimes is like, what if you have like 123, right? Like, would it be like this or would it be like this, right? And again, this like kind of changes how you can need to write the algorithm. So you should be like thinking about like, okay, what are my inputs, etc. And by the end of this phase of questions, you should be as much of an, like you should be able to, given any input, you know, understand like fully understand the problem to the point that you could give this problem to someone else. Let's see, are there other ones? I think I answered. So there isn't seconds. I would say that given that there wasn't if there was already an example that didn't come with seconds, I think it's generally safe to assume there's no seconds, but you can still make that quick comment like, okay, so I'm assuming there's no seconds. We don't care about that. And it's like, yep, no seconds. Okay. Cool. So this, let's continue here with our, I think we covered generally the questions that I would have expected, and noting that we should obviously spend a lot more time in the happy case. We'll come back to that in a second. But so after we've kind of fully understood the problem, and again, I like to say slow down to speed up a lot. I do think that as you're practicing this, I almost would think about these steps and mentally, you don't have to announce it or anything, but mentally tell yourself, okay, I'm ready to go on to the next step, just to make sure you're like checking the boxes, right? Because you can kind of prime your brain to try to think about the problem in certain ways. You're like, have I really thought about all the cases? Do I really make sure that I like understand my input, output, etc.? So now it's like, okay, let me start thinking about solutions, right? And a few things that people, just to kind of, before we start doing this, is identify a simple solution. And this is, I think, underestimated. Like, I think a lot of times people immediately try to think of something that's super optimal and like coming up with complex data structures and things like that. And it's like, you know, again, it's not about a single right answer. It's the journey to get there, right? So if you can quickly identify a brute force solution, like let's just call sort, that's great. That actually gets you a few points probably, right? In this interview, you're like racking up something, right? And yeah, so like identifying not just simple, sometimes it's, sorry, not just brute force, sometimes it's just like the most straightforward approach. Work through some example cases manually. This, in the problem that we just did, it's almost impossible to separate these two because like you have to like solve the problem in order to do it, but not always. And sometimes you come up with the examples and you don't need to, you kind of just know this, the thing, but you should be working through some example cases, right? Don't even worry about like the algorithm, right? The 0, 1, and 2 case is great. It's like that one you should just come up with a bunch of examples and just start working through them, right? And just ask yourself, what am I doing? What am I doing, right? And I think you should be thinking about, you know, expected time and space complexity as you're exploring these different approaches. And again, with all of these problems, it's like, don't just like try to jump straight to the correct solution or whatever, right? Like you should actually be kind of going through and identifying as many different approaches as possible. So I guess with each of these, can anyone think of any approaches for like the 0, 1s, and 2s problem? So we already have solution number 1, it's just call sort, right? Anyone else think of any high level solutions for this?
I mean, I would manually go through it, the examples first. So I would manually be like, all right, I'm going to look at 2 and 0. And then if 0 is less than 2, and then compare, and then I would kind of keep moving along the array.
So kind of compare things pairwise.
Mm-hmm.
So it's almost like a bubble sort type of thing, right?
And then I would hope that the clock on my interview would run out before I got to optimizing, because I need algorithms and I use sort method every time.
So that's actually an interesting thing that you mentioned, the interview clock, right? In general, this is like a meta interview prep tip, is that I do recommend sometimes practicing in an interview clock setting. I don't recommend it always. Like sometimes you really just want to give yourself, sorry, hours of time to really soak in approach and not rush yourself. But actually, sometimes I think it's helpful to have an interview clock. And sometimes, you know, our decision on what to do in an interview, actually, the amount of time left on the clock is an input to that decision. Many times I will look at my clock and I will say, like, you know, there's like a try approach where I can use a hash table and like a reverse lookup priority queue to solve this most optimally. However, I'm not going to get that coded up in 20 minutes. And so I'm going to go with an approach that is actually much easier to understand and code, even though I've come up with the other algorithm, right? And that's actually a better move. Like if someone does that, that actually is stronger to me than trying to, like, having no self-awareness to think that like I can actually implement like this really complex one. And so, but that being said, I like if we were to talk about this like bubble kind of approach, I wouldn't spend all my interview time doing that, right? Like I would, like we should talk about that solution at the verbal level, but not spend that much time doing it, right? And so it's good to kind of like call it out as a possibility, but then, and then you get credit even just for identifying this as a solution. So you've already like won in some extent, but then also like identify some alternative approaches. Now, what are some of the downsides of bubble sort? And actually, I'm not sure if everyone's familiar with bubble sort.
I would have to loop a lot, right?
Slower?
Oh, go ahead, whoever was going to talk.
Oh, I was gonna say it's slower and efficient.
What does slower mean? What's the runtime?
Oh, I'm not very good at runtime. So the runtime is n
Yeah, it's n squared actually.
squared.
So, and obviously, again, this is kind of foundational stuff that we're not covering as part of this, but generally, like if you look at runtime, there's like there's really only a couple of options. It's usually like log n and n squared, and then like exponential to the n. Sometimes there is like factorial. Then there's some like combinations of like a plus, like a n plus k type of thing. But I would say, honestly, these ones are probably the most common ones, right? And so as you start working on these, it is useful to be able to categorize these algorithms as like which ones of these is this problem. And actually, you know, when we did this one called sort, I would say that the standard expectation for a standard sort is n log n. And so I would assume that if I was calling the built-in function, it is already n log n. And so really the point of the rest of this interview is see if we can do any better than n log n, right? So bubble sort actually has a worse kind of runtime than the most optimal sort algorithms. I won't go into why, but it is still an option to consider or list out. But what are some other? Can anyone think of a more optimal way to try to sort this?
I was always told, sorry if you're my child in the background. I was always told interviewers look for hash tables. I don't know how true that is.
So hashing solves a whole set of kind of problems regarding lookup. And so yes, but a hash table is just a tool, just like a hammer or screwdriver is a tool, right? If you have a screw and you have a hammer, your hammer is not going to do you a whole lot of good, right? You're going to need a screwdriver. And so obviously like the same tools don't work for all problems. And so you want to kind of get used to the classes of problems that various data structures and various classic algorithms can solve so that you can call them. Yeah. So Callie is pointing out that since it's just 0, 1, and 2, we can speed it up a lot just by knowing that, like leveraging that fact, right? Yeah, merge sort or quick sort. So merge sort or quick sort are all kind of like things that fall under this category, I would say. They're just general sort algorithms that are n log n. So they're better than bubble sort in that their average runtime or their runtime is, n log n now, but they're still not utilizing the fact that it is just 0, 1s, and 2s. So I think, yeah.
But a question to ask, I don't know if it was are we manipulating the current array or can I make a new array?
Yes, actually, that's a great question. And you can use the technical term in place or not. So if you're sorting in place, it means you're modifying the original array, and otherwise you might have to create a new one. Let's start with you create an up to you, basically. You can do it in place if you would like to. If you're doing it in place, however, it's really interesting because it's actually a little bit harder. So let's say that we're doing it in place and we're iterating through the array, right? And let's say that this is our input, right? And so Callie's like, oh, I see a 2, I'm actually gonna move it to the end, right? So a few ways you could swap it, right? Or you could, if you just move it to the end and now it's like overwritten there, you've forgotten kind of like what it is. Or you're swapping it, but then do you know which parts of the array you've like finished or not, right? And so doing things in place can be like trickier than just like not doing it in place and then like creating a new separate array later. So I would say not in place is likely easier, but in place is potentially better for like memory, right? So I think someone was starting to, oh, so yeah, let's just count how many 0, 1s, and 2s, right? So that's great. So let's just say that we, kept track of how many 0, 1s, and 2s there are. And okay, let's say this was our input, right? Sometimes when I come up with happy cases, sometimes I create one that's just a lot bigger, right? Because it actually forces you to come up with more of an algorithm in your head. When you see this, you're like, oh man, I can't just like instantly see the answer. You might automatically start thinking, oh man, let me just count how many zeros are there, right? How many ones are there? And then you start naturally building that algorithm, right? And so this new kind of approach is like, we're going to keep track of the number of 0, 1s, and 2s, and then we'll just kind of make a new array, right? So we're going to have this, then we go like this, we keep moving through and counting up how many we've seen, right? And at the end, we'll have 1, 2, 3, 4 1s, 1, 2, 3 zeros, and 1, 2, 3, 4, 5 2s, right? And then, sorry, this was 3. Yeah. So then once we get this kind of set, we can kind of recreate a new array or override the original thing. And now it's better. Anyone who's studied runtime or space want to give a stab at what we think the runtime or space complexity now is? Oven? Yep.
So I
Yeah,
always
that's
think
exactly right.
terms of looping, because I'm not a lead coder and I just do things at work. So like I think of how many times I'm looping. Does that correspond to these O's? And how would I think about the different O's? And is it like a one-to-one with like thinking about how I do it at work, where I'm like, okay, well, I want to loop through things as few times as possible, or is it not kind of correlate like that?
So this is interesting. Let's change the algorithm just slightly.
Okay.
Instead of like counting them up, and I was showing everyone how I was like saying like, oh, this is a 2, let me increment this, right? Instead of that, let's change the algorithm to be like, okay, I'm going to loop through it 3 times. The first time I'm just going to count the number of zeros. The second time I'm going to count the number of ones. And the third time I'm going to count the number of 2s, right? That's just what I'm going to do. Focus on one number at a time. So as humans, we wouldn't do that, but let's say we did that as the algorithm. How does this actually change our runtime? Does it change our runtime?
Oh, because it's now 3 times as much. So that's.
So it's 3 times as much.
Yeah.
And it's kind of 3 times n sort of when you think about it, right?
Yeah.
But it's actually the runtime does not change. So the
Oh,
big O runtime is completely the same in this case.
I
They're
was gonna
both O of n.
Is it based on if there's a loop within a loop and not necessarily how many loops are within
Yeah.
a function?
And now I can further trick you here where it's like, let's say we have a loop, right? And it's like for I in 0 to like array dot length, and this is not real syntax, but let's just say we're looping through the array, right? So this is an O of n loop, right? We're looping through all of the elements in the array. And then we have another loop inside of it that's like for j in 0 to 2, right? You
Because
see two, yeah.
O of 3n versus O of n in the grand scheme of things isn't that different?
Yeah, it doesn't matter at all, because if you think about it, right, like as we're iterating, we're also doing some amount of work, right? And the amount of work could vary significantly from array to like item to item. The whole thing of like, so for example, if you were to say like sort like 1,000 element array, right? Well, okay, that's not a good example. Find the first, okay, I'm like struggling to come up with an example, but so the runtime is basically like, as your input gets bigger, how does that change like how long it takes? And if there's no, so for example, find the first element in an array, right? No matter how big your array is, if it's 1 element, 10 elements, 100 elements, 1,000,000 elements, it's always going to take exactly 1 work to get there, right? It's not changing at all. So O of n is basically like if you have n times more items, you're going to have to roughly do n times more work, right?
Okay.
And log n is if you have to do a fraction of that, essentially.
Okay.
Fraction's not the right word. It is basically a log amount of the work. So if you've heard of like binary search or anything like that, if you go from like what a size of 1 versus 100 versus 1,000, if you were to use binary search to find something, you would only go from like 1 to 3 to like 5 type of thing, right? So your amount of work changes much slower than the size of your array. And so it's not quite just exactly how many loops, it really depends. So the nested loop example here, right? Even though we're seeing a nested loop, this is a finite amount of work. It is always 0 to 2. It doesn't fluctuate based on the length of your array. And so this inner loop doesn't even matter, right? Like let's say it's like console.log, right? Assuming this is like a constant work inside here as well, then this whole thing, even though it's nested, is still O of n. Because again, as your input size changes, this part doesn't change at all, so it doesn't matter. So anyway, O of n is correct. Yeah, you can always just drop the constant. O of 3n completely the same as O of n. And so this solution is actually O of n. Now, there's actually a slightly better solution in this case. And I'm not going to walk through it fully, but it basically is a solution that does not change the complexity. However, it makes it so you only have to do one pass of the array. Right now, we're required to do two because we count them in one pass and then we create the array in a second pass. The most optimal solution to this is actually very interesting. It requires you to like have 3 pointers. So I'll say this is N, this is start, and then there's like an I. And by the way, what I'm doing here is also a communication skill. So one of the things that I practice is actually being able to quickly kind of show loops, right? And being able to like quickly do this and use space to show me iterating through things and being able to do that while talking is something that helps you feel more comfortable in an interview, right? And so basically the solution is something like, if you see, this is actually exactly what you were doing, Callie, which was when you see a number, if it is a 2, then you swap it with the element at the end. And then when you see, a 0, you swap it to the beginning. And if you see a 1, you kind of keep it to where it is. What you need to do, however, is you need to kind of keep track of where your like ends are, because the next 2 you run into, right? So this one we leave put. The next 2 we run into, we have to now swap it into this position instead of the original position. And so we're going to kind of swap it. Oh, sorry, this was never supposed to move past here. And then when we see a 0, we swap it with the start. So, so now 0 goes here, 1 goes here, and then we increment both. And then now we see a 0, so we swap it with here. Yeah. And so on and so forth. And when we get to this 2, we swap it. We forgot to move this E. Anyway, something like that, right? This solution, though, is one where I would kind of bring it up, but depending on time, I may or may not implement this because there's actually a lot of tricky edge cases here to make sure you're getting all of the like maneuvering correctly. This one is way easier to implement. Like I can see the solution like in my head, like all the lines of code. It's way easier, although people still get more tripped up than you might expect. And so, but this is kind of like a good one to kind of like bring up. And I would roughly describe this as like using 3 pointers. I'm going to just move the, zeros to the left, choose to the right, and keep going until our pointers have met. Cool. I don't think we have time to go through the other ones, so let's just keep going through the rest of this. But the next step is really choosing the solution. Again, when choosing the solution, like the most optimal solution isn't always the best showcase of your actual coding ability. The ability to come up with what the most optimal solution is kind of useful because you should be aware that it's an option for you. But you totally don't have to actually choose that to be your showcase in terms of the coding, right? There actually might be more interesting code to write than the most optimal solution. And so, I would at this stage kind of like look at all of the options that you have in front of you and kind of talk about which one you want to do and align with your interviewer on like, okay, this is the one I'm going to do. I think this one's the best because whatever. I will say maybe at least 50% of the time, if not more often, it does end up being the most optimal runtime and space basically solution, but it is definitely not always the case. The kind of next thing is I generally recommend for people to kind of like break down and start writing your code in like a pseudocode fashion. So breaking down the problem into smaller problems. So for example, here, instead of just like starting to code the solution, I might say something like, you know, just start like laying things out. So, you know, count the number of zeros, ones, and twos. Create a new array. And then just start kind of like mapping out like the sections of your code. And I might even start like writing some more detailed pseudocode. So for example, like I might start having, you know, if I'm 0. And by the way, here there's actually interesting variations where sometimes people will create a dictionary or a hash table to map from like the numbers to the counts, or they might have an array that's like counts that's just like 3 elements big and it's like 0, 1, and 2. And so there's actually like interesting kind of little decisions like that along the road that you can make. But I would absolutely start kind of like creating some gutter guards and guardrails for yourself as you're starting to make this. I don't actually know if this is the best example of this, but sometimes, for example, I'll even create a helper function. And the helper function is like does a subsection of the algorithm for me. But it allows me to focus on kind of like the meat of the algorithm without dealing with like some like, for example, we could say like count ones, twos. This, I probably wouldn't break it up this way for this problem, but like if there are certain ways that I can remove complexity to like get something on paper first, that's something that I might consider here. And then we will go through obviously the coding piece, and then I want to quickly talk about testing. So one of the, this is me going again, one of the most common mistakes that I see in interviews is that people will write their code and then be like, okay, I think I'm done. And it's just like, I think when I say it that way, people are like, oh, obviously I wouldn't just stop there, but people do it so often. Like they just forget somehow to test their code. The testing might be happening in your head, but it's kind of just like, I just see people getting to the end. They're like, okay, and then I think all I have to do is return, you know, this thing. I think I'm good, right? That is, I would say, like, it's definitely not an instant fail probably, but very, very close. Like if you don't test your code, it kind of shows your engineering thought process, right? Like imagine writing code in production and then not testing it, like running your code and see if it works with the real user and then just shipping it, right? Like that feels like the equivalent of that. And so again, going back to the theme of this is like a condensed version of a real engineering process. It's very, very important for you to then take your inputs and actually walk through your code and verify that it works. The good news is if you did kind of explore a lot of happy cases and encode the examples from earlier, you should have already done a lot of this work. You should already have exact test cases that you can just plug into your function. So like this step could be much faster. But yeah, Callie.
Yes, I'm curious if okay, like I think I would run out of time before I came up with the 3 pointers. To be honest, I don't think I'd come up with it at all. But would you prioritize coming up with like the most optimal solution and running out of time to finish the code / writing tests? Or would you prioritize getting code written and getting tests written over having the most optimal solution? Or would you just ask your interviewer during the time what they would prefer?
Yeah, and I think that it's actually both. So generally, and this is kind of why I recommend occasionally testing or practicing being on an interview clock. You actually should manage your time. And I think that you should generally have an opinion. So usually I like to confirm with my interviewer rather than ask. And I also like to confirm rather than assume. So it's kind of in between asking and assuming. So sometimes people will just like go and implement something without confirming with the interviewer that we're good. And it's kind of like, well, I didn't want that, but they're just running ahead with it, so whatever. Or it's like too passive where it's like, if, I want you to be able to independently work, right? Like, and if you ask me for permission for everything, then I feel like you can't, like exercising judgment call. I want to see what your judgment calls are, right? And so if you're just like, should I code now? Should I do this now? Should I go for a more optimal algorithm? Should I do this? Then I'm like, okay, this person can't, doesn't have judgment call. But so the in-between is, I think, the optimal thing where you're like, okay, based on the fact that we have 40 minutes left or 20 minutes left, I think I should get started with code. I think this is the right one because it is the simplest approach. Are we good with that? And the person's like, great, yes. Or they might be able to correct if there's something that you're not like considering yet. So yeah, I think work with your interviewer, keep track of the clock. If you feel like you're starting to run low on time and you need the rest of the time to code, I would suggest, I think I should get started with coding. What do you think?
Okay. I also feel like when I'm coding at work, I would make it work and make it pass my test before I optimized it, because then I'd be able to use the test to verify that my optimization is working.
Yeah, it's like test-driven development, right?
Yeah. Well, I mean, let's be real. I always write my tests after I make it work. But yeah, so I wouldn't put me in that category. But yes, I feel like I would be nervous that my tests would be wrong if I wrote them too quickly for like the most optimal solution. But anyways, I think we're getting some chats.
Yeah, it's definitely, you're almost always coding. I don't think I've actually seen many interviews at all if you're not primarily the one coding. I know in this demo where I'm doing that to save some time, but that's definitely not typical. This is what I normally do. Does that work for you? Can you clarify, Christine, what you mean by like, this is what I normally
Oh,
do?
that was like earlier when you're talking to Callie about like setting the pace, but you don't want to like just assume, but you don't want to
Yeah,
question it too much.
yeah. I guess the only thing is that like you're not typically solving problems like this, so it's I guess maybe this is what I normally do sounds a little weird because you're probably normally not sitting there solving these problems. But like, yeah, I would just say like, yeah, I think I'm ready to get started with coding, or I think this is the right. Yeah. I think there's someone else that had a question.
I do have a question. So, my question per se is like, I've been on interviews and stuff like that. And to be honest, I've actually got a question like this about arrays. I did some iteration with the questions as well. My first thought when you gave the problem was just do like a for each loop and kind of like do like from ascending to descending. So I would sort it out in ascending order and descending order because it says return a sorted array. So I would use a for each loop to kind of do that, or I would just kind of create the array from descending to ascending. I know you said create happy cases and really thoroughly understand the problem. And I saw a lot of the things that you did with the var zeros, var ones, and var twos. I just feel like with the timing of an interview, you're not going to have time to do all those variations. So what would be like the most efficient way to just go about a problem like that once you see it?
Yeah. So, and actually like, so if I was describing those solutions in an interview, I probably actually wouldn't spend all that much time on each thing. So I think that like the way that I would probably actually do this is I'm like, well, we could use any of the standard sorts. That would be O of n log n time. I'm assuming we want to do a little better than that. So let's see, what else can we do? And that's all the amount of time I spend on that first case, right? And I'm like, well, since they're just 0, 1s, and 2s, I think I could, just keep count of each one and then recreate the array based on those counts later. And I actually, that's it. That is all the time that I would spend on that portion. I'm like, by doing it that way, I think we would reduce the runtime to O of n in that case. Now, sometimes I will describe an algorithm and maybe, again, depending on how clearly you're able to describe it, maybe the interviewer doesn't understand what you're saying, right? And this is where communication really is important. So to be honest, I didn't fully get what your approach was that you were kind of recommending, but since I didn't understand, then I might actually ask you further, like, wait, show me what you mean by that, right? So like, what are we actually doing here? And only in that case would I spend more time kind of like describing like exactly how it would iterate through the array. And so, yes, all of these problems, like all of these solutions, I might not actually spend very much time at all. I might spend only like 15, 20 seconds talking about it in theory. And then I would only implement one of those solutions as part of the coding, if that makes sense.
Yeah, that makes a lot of sense. So basically, from what my standpoint, what I think is the very first way you did the solutions at the top, those very first iterations of how you basically did the what is it called? Right next to the top of the question, right? I feel like where you organize them from descending to ascending and how you did where the mouse is clicking basically. I feel like that is what I would have given on a coding interview and explained that. And if given more time, like you said, then you would go into the explanation of other, like you say, happy cases, different sorts of solutions and getting into that.
So examples are also not solutions, right? So like if I listed out more cases like this, that's not necessarily like different solutions, right? These are just a bunch of different examples. So I do think that like listing out at least a handful of example cases is useful, right? So like, yeah, I think here, for example, I would list maybe some examples that are a little bit different. And if you're asking like how many solutions to kind of like walk through, it really depends on like the question and how confident you're feeling on the problem. If you feel like you fully understand the problem and you don't need any more happy cases to help you feel confident, then you can stop, right? In the example of this timestamp one, actually, when I run this problem, I feel like I spend almost like 30 minutes walking through examples with people typically, like literally just constantly like, okay, well, what about this timestamp? Like, what am I doing? And it's very interesting. It's a different problem. For this problem, I think you're right that like I'd probably spend like under a minute coming up with like 2, 3, maybe 4 example inputs, and then that's it. And then I'm moving on to like solutioning. So it does depend on the problem as well.
Okay, I get what you're saying. So it's really dependent on the programmer. Like if you feel comfortable with that first case, then you can keep that. But you know,
Yeah.
I like what you said about different happy cases, different examples. So you can basically have more options to vary with the interviewer and stuff like that.
Yeah. Yeah. And also like it depends on how many kind of cases there generally are. Like like if you are you're dealing with a tree problem, like oftentimes there's like a lot of variations that you may want to test, right? Like and really like this set of examples, like another way to think about it is like, what are all of the cases that you would want to test to give yourself confidence that your solution works, right? At some point, you're going to say, I stand by the solution and I believe it works, basically. And whether you're correct in that judgment is actually a big part of it. That's is it right or not? Does it work or not? Now, it's definitely by far not the only signal, but it is one of the stronger signals, is when you have declared this to be working. Is it working? Right? And so what are all of the cases that you want to see to give yourself confidence that your code is working? And sometimes like for certain problems, you're like, okay, I want to test a tree with a height of 3. I want to test one where there's just one level. I want to test one that's imbalanced. I want to test one that's both that it's balanced, right? And so yeah, like ultimately, I think the goal should be to gain confidence for yourself. Okay, and I was assuming since this originally was scheduled up to 6 that we did have roughly that amount of time. So I know that we're roughly getting close to there. So so in terms of what we want to do with the last like few minutes of our time, do we want to just have like continued open and Q&A about general interviews? Do we want to try to code up some of this particular solution and walk through the rest of it and go through the testing? We'll have to go through it probably pretty quickly, or what do we think is the best use of time for the last few minutes?
So let's do real quick, do like a thumbs up emoji if you want to do Q&A. I need to change my view because I can't see what people are doing.
I was wondering with the testing, what do you mean by testing? Do you do like a test suite type?
Yeah, great question, actually. So what I usually do is I will actually convert. I'll either start doing this from the beginning, or I will convert this set of things into like actual like this thing, right? And so I would probably structure this like this. And then now I can run the code. And one little super practical tip is sometimes I'll do it this way. So it actually prints, sorry, I didn't call my function. That would be helpful.
Be like, it works.
Right? And then one kind of super practical tip is sometimes I will do this. So I'm putting the solution next to it. It just makes it easier to kind of like compare. Where's my problem here? Okay, I can't even.
I think it's an extra closing parenthesis on 35 minus and then so change that yellow parenthesis to comma. But it's minus the yellow parenthesis. There.
Yeah, great. Okay, now what is it? Oh, okay, we didn't actually have this. But anyway, yeah, so that way we can see kind of like side by side otherwise when you have a bunch of test cases, it's like hard to match up which one you expect which. But yeah, I literally would build this first. And actually, I kind of like doing this, writing this first. It's basically test-driven kind of development, basically. Sometimes I don't find test-driven development that useful actually in practical coding because anyway, but in interviews in a more like confined, these are cleaner situations, I actually do find like writing the test cases first to be useful. And if the code isn't working in the beginning, I usually like to work on one case at a time. So I might, comment a bunch out and just work on this one case. And then once that's working, uncomment the rest and keep incrementally covering more cases. So this is a great question. Are hints during an interview, you're going in the wrong direction? So I would say that like a lot of times people view interviews as too binary. And again, like people think like, oh, I'm able to do this. I succeed at this interview if I get the right answer. And again, that's not true. And I would say there's things that help you and things that take away. And I would think of it as almost like there's like points, right? Like you're accumulating points throughout the interview process, and some things also hurt you a little bit, but nothing is binary. So I would say, for example, identifying a brute force solution, that is already like you're gaining points, even just by saying that. Being able to analyze like a particular runtime solution, that is part of it, right? And again, when you declare that solution is working, that's a pretty big swing, right? But it's still not the whole thing. I would say hints are sort of like that. I do think hints like detract a little bit, but I would say like the first couple probably don't matter at all. Once you're starting to get into like, now you're getting a ton of hints, they start to like detract from your interview performance right away. Slowly over time. But again, like you can still, it's not like the only thing that's going to dictate your performance. I would say that in a typical interview, I probably give like 1 or 2 hints, even in a like passing interview. And if the person does really stellar on certain components of it, it can even be more than that. So for dynamic programming, generally, I would say no. I think that a common interview kind of prep mistake that people make is that they are practicing problems that are way too difficult. Just imagine like, you know, a baby trying to practice how to do like a sprint or something like that. Obviously, you need to learn how to walk before you can do more advanced, like, or if you're like practicing figure skating, you're not going to do like a whatever, like triple axel, whatever. You're like, even if that's what your goal is, that shouldn't be what you practice, right? Like you should practice much simpler skills and be mastering them to a very like confident level before doing. So I would say that the average leak code problem, even the easy problems are, in my opinion, like way too hard to start with if you're just like starting to practice. And so I would only learn dynamic programming if like most of the other problems feel quite easy to you. And there's only a select handful of companies that actually do dynamic programming as part of their like coding assessment. So it's like you just don't get as much bang for your buck in terms of like interview performance lift than if you focus on kind of the more common topics. How long does it take? I mean, I think that the quality of your practice is the most important thing. I have seen people do literally 500 leak code problems and still not be ready. And I've seen people who do a fraction of that and be like exceptional. And so it varies so much. It's one of the things that I observed, which is why we do adaptive learning. Instead of, you know, this is what I have with problem with YouTube videos and things like that in general is like after you've watched a video or you've like followed a tutorial, you probably have no idea if you're now performing at the level that is expected of you, right? Like you don't know if you've retained enough of the video, if you're able to, you know, recall all the things that you need to efficiently enough and all of that stuff. And so like I think the quality of if you're practicing the right difficulty and in the right ways, again, like, you know, sometimes practicing with interview clocks and sometimes not, like massively swings how long it will take for you to be ready. Whose
Sophie?
opinion? Yeah.
I have a question. So if a technical interview is not like a whiteboarding or, you know, like the elite code problem, but more of a like a real world problem on hacker rank or
Yeah.
something like that. Like, so we're still talking about communication, right? But then you probably would want to Google something. Like how much Googling is too much?
So even in normal interviews that are live, like looking up syntax is always totally fine. I think it's like the equivalent of like using like calculator to solve basic arithmetic for like, I don't know, like more in you know, like math problems.
So
Like
like you would say like
chemistry problems.
MDN, like docs, that would be fine to look at.
I always just confirm with the interviewer like what's okay, but like yeah, generally like engineering again, like if we're always the interview process is attempting to capture a pretty condensed version of a real engineering problem lifecycle. And by the way, this engineering method is meant to be applied to all engineering problems, just like the scientific method is meant to be applied to all kinds of like scientific research. And it can be like really quick problems like coding interview problems, or it could be month-long problems or like, you know, months-long problem that like you're solving that's like a big feature. And it can also be applied to like, you know, take home style projects that are more realistic. So really the whole process is really the same, like in terms of problem discovery, you know, going out and like trying to come up with like various approaches and things like that. And then, but yeah, in terms of like what resources you can use, I would just ask the interviewer. But like, the reason I say it's usually not a problem is that like I don't consider like when I am solving a problem, typically on the job, I have access to the internet. So anything that I can pull up really efficiently is not useful. Like I don't care if you have that memorized as an engineer in the real job. And so therefore I don't care about that in the interview process either. But yeah, I'm actually sorry, did that answer the question?
Yes, thank you so much.
Yeah.
And thank you for sharing all this valuable information and being here. We really appreciate it.
Yeah, appreciate all of you guys for being here. I'm going to try to get through, you know, all the questions. But, you know, if there's anything else that I can be helpful with, feel free to also reach out to me on my LinkedIn or anything like that. I'm sure we can stay connected. And if there's future ways that I can help this group, Callie, definitely we'll stay in touch. And you know, I really am like passionate about helping people from different backgrounds find their ways into tech and advance their careers in tech. And so happy to continue to be a resource. In terms of, okay, opinion in the hiring process, I think it's too vague of a question. It depends a little bit. I would say that typically you would want, it depends on the company, but if there's it, you generally want all kind of yeses and someone who's like somewhat of a strong yes. So you kind of want one voice to be like fighting for a person. If there's any like interview, and then yeah, in terms of like, it also depends on the role. So like for a more senior role, like the system design interview might actually pull more weight because it is more applicable to like what they need to be doing. A more junior role, the coding interviews might be more important. For an iOS role, the domain expertise interview might be more important because it's really more about like that domain knowledge that the person's bringing in. So I think it does kind of depend on the person or the role. In terms of books, I'm actually generally like really bad at languages. I like to almost brag that I don't know any programming languages because I don't code day to day, and so I switch between like languages a lot. I actually, for the purposes of algorithms, sometimes even recommend just coding in different languages because it forces you to think about the underlying logic and like the transferable logic between things rather than focus too much on like the language. Languages come and go and they change. And so usually deep technical expertise isn't developed at the language level. It's at least at the framework level, if not higher. So I don't get too kind of hung up on like specific languages. And in terms of books, I also usually think that books are good for reference. So like if you're having a specific problem, learning about how to, but as all things engineering, I would recommend doing to learn and not reading to learn. So I would not like take a book and read it from beginning to end and be like, okay, I hope I know all this stuff. I would solve real problems and in the course of that run into problems and then use the book as reference to solve those problems rather than like using them as a more traditional book. But okay, I think we actually got through all of the questions and I know we're a little bit over, so appreciate everyone staying a little bit of extra time. I'm sure everyone's like hungry and wants dinner or something like that. So again, appreciate the time. And yeah, Callie, is there anything else that you want to wrap up with before?
Oh, just thank you so much. This was so great. I learned a ton. I'm sure everybody else learned a ton. You're probably about to get a bunch of applications to formation and be like, wait till you're mid to senior level, but this was really awesome. Thanks so much. Everybody, let's thank Sophie, and I'm gonna just kind of close the Zoom down, so.
All right, well, thanks everyone. So nice meeting all of you and best of luck in all of your engineering journeys and I hope to stay in touch.
Yay, this is great. All right, guys, see you later.
Bye, everyone.